Okay, so quiz tomorrow on all the vocabulary and all the things we've been doing. So today we're going to use what we know about the distance formula to help us find perimeter in the coordinate grid. So let's talk about perimeter. You guys, what is a perimeter? Yeah, the outside, yes, but more specifically, what do you mean about the outside?
Outside links added together.
Okay, the outside links added together. It's the distance, if you'll fill that in. It's the distance, so our distance formula is going to come in handy. The distance around a two-dimensional shape. 2 dimensions means it's got length and width. Is it a T or an S dimension? S? T?
Dimension.
Is it an S? What did I write on my notes? Yeah, it's an S. It's an S, dimensional. Yeah, dimensions is an S, yes. Okay, so the distance around a two-dimensional shape, and how do you find it? Add all the sides. So we'll put in there, add all the sides. So no matter how many sides the figure has, you can always find a perimeter just by adding them up. Add all the sides. So what would be the perimeter of this rectangle? 20, yep. 7 and 3 is 10, 7 and 3 is 10. Yeah. How about if all these sides are 3 and there's 5 of them, what's its perimeter? Yeah, 15. So you can add all the sides. Once you know the length of each side, you just add them all together and that gives you the perimeter. So that's going to be our job today, is to find the length of each side. So the perimeter of a polygon is just any sided figure, is the distance around it, and you can find it by adding all of its sides. So we can calculate any unknown side by either using the distance formula, we're going to try it that way, and then I'm going to show you how you can actually use the Pythagorean theorem too as an option to find the distance. So we know the distance formula, we've got to know it this year, finding the difference of the x's squared and the difference of the y squaring it. Excuse me, so you're going to find the perimeter of triangle ABC with these vertices. So your first job is going to be to graph it. So graph it on yours, -2, 3, and it's not a bad idea to label them with the ordered pairs, and you'll see why in just a minute. Some of them you won't need to as you get going, but as we start this, let's do that because it's going to come in handy. So 3, -3 is B at 3, -3, and C is at -2, -3, and -2, -3. It only takes a second to write them down, and it will be helpful. You'll see why in just a second. Now connect them as best you can. I do have rulers if you would like a ruler for your figures. Okay, now we're trying to find the perimeter, which means we need to know the length of all 3 sides. Could we figure out any of the sides right now without much effort? Yeah, the straight ones, right? Yeah, they are legs. Yeah, it does happen to make a right angle. So what's the length of our vertical side? Everybody got 6? And what's the length of the horizontal side? 5. Now all we have to do is figure out the length of the other side. Now let's practice using the distance formula on this one. That's why it was helpful to write these coordinates down so you're not bouncing back and forth trying to remember what points am I using. They're just there. So let's find the distance of AB using the distance formula. Let's practice that. So we got to do our x's squared, our y squared, subtracted, all that stuff. Grant, tell us how to find the first legs with the x's. What do you do? Good. -2 minus 3. Okay, the y's. Devin, tell us how to find the y leg. 3. Good. Plus 3. Perfect. So -2 minus 3. What do we get? -5, 3 plus 3, 6, square them, it's -5 squared, 25, 6 squared, 36, so 25 and 36 is 61. And we'll need to know the decimal form because we got to add up all the sides. We're not going to be keeping the radical, in the future you will, but let's get the decimal form and let's round to the nearest 100. The assignment asks for the 100, 37.81. Okay, so label that one. Now we know all 3. We can find the perimeter of the triangle by adding all 3 tell me what you're getting. 18.81, and we don't know if it's inches, feet, yards, whatever, so you can just say units. 18.81 units. Okay, so no big deal. Okay, let's look at the next one. Your first job will be to graph it, and I know I didn't print the best, but let's graph, so we've got a quadrilateral this time, a four-sided figure. Let's graph -2, 6, and call it E. I would write those coordinates on there. F is at 4, 3. 4, 3. G at 4, -1. -1, and H at -4, -2. Okay, so it just takes a second to write them on there. It just helps out when you're using that distance formula to have them written on the, on the segment you're trying to find the length of. Connect them as best you can, as straight as you can. Okay, so we gotta find all four sides to add them together. Could we find any of them right away? FG, it's the only one that's perfectly straight. How long is FG? 4. Okay, so let's put that over here on FG. We're gonna find it. Now let's just go in order of the steps on this one. It says to find the length of EF first. So we're gonna use the distance formula on this one. I'll show you another option in a minute. But let's use the distance formula from E to F. We're going from E to F. Tell me the X's I've gotta use. -2 minus 4 squared plus, Maya tells us the Y's we've got to use. Good, 6 minus 3, E to F. You can go the other direction, but whatever you start with, go with that. So you're going to get really fast at these. -6 squared plus 3 squared. Here's what's -6 squared. 36 plus 3 squared. 9, add those together. Okay, so it's 45. So square root that to the nearest hundredth. 71. So
Yeah.
6.71. So that was EF. So let's put that on there. 6.71. Now we'll do the same for GH. Get a big radical for GH. Michaela Cotton, tell me the X's we got to use to find GH. Okay, so she went -4 minus 4, so we gotta follow that pattern. She went -4 minus 4, so then I gotta start with -2 minus -1, so you can plus 1. Does that look right? Did I look at the right numbers? Okay, -4 minus 4 is -8. -2 plus 1 is -1. What's -8 squared? What's -1 squared? 1. Adding those, square root of 65, nearest hundredth. Sorry. GH.
Because it'd be 4 plus 4.
If you go that way, yeah. But she chose to go -4 to 4. So you should still get the same answer no matter what. You can go G to H or H to G, it doesn't matter. 8.06. Yeah, that's super close to 64, so it should definitely be close to 8. So 8.06, final leg, not leg, side. Final side, let's get it. HE, H to E. Emery, tell me the X's we gotta have HE. Which other order do you want to go in? Plus 2. Okay, so she did go H to E plus, so we'll go H to E on the Y's. Well, then give me the Y's going H to E.
-2
Minus -2? No, that's a positive. Something. 6. Yeah, -6. Okay, so we've got -2 squared plus -8 squared, yeah? Is that what everybody got? -2 squared is 4, and 64, adding those, square root of 68, what's our 25? Okay, so now we finally got them all. Let's add them all up to get the perimeter for the last step. Add all 4 sides. Tell me what you're getting. 0.02 units. Perimeter is 27.02. So the distance formula works to find any length that's not perfectly straight or short. Okay, so now I'm gonna, we'll do one more distance formula. Okay, this one, just a triangle, so let's plot those points at -3, 4, A is at 4, B is at 4, 4, and C is at 1, -3. Connect them as best you can. What length can we find right now? AB is the only one perfectly straight. How long is AB? 7. Put that one on AB. Let's find BC. Marley, help us with the X's for BC.
4 minus 1.
Go
4
ahead.
plus
4, sorry. Is it 4? 4 plus 3. That look good for everybody? She getting right? From B to C. Okay, so that gives us a 3 squared and a 7 squared. We know 3 squared, what's 7 squared? We haven't done that yet. 49 plus the 9. 58, nearest hundredth.
Look. I think you should just look at it.
7 point what? 62, that was BC. Okay, length of CA, Nick, get us going with the X's for CA.
Okay, so, 4, oh, sorry, CA, 1
3 to
minus
Okay,
-3,
1 minus -3, okay, will you tell me the Y's?
4 minus
Plus, plus. So we've got 4, did I do that right? And 7? Okay, so 16 and 49, what do they add? 65, square root of 65? 0.6?
Yep.
No. Okay, the perimeter then, adding them up. 68. 68. So you can always use the distance formula for sure. Question?
Why'd you read the whole stuff on? This is actually so.
If we do 1,
It'd all be the same
Plus
thing,
3.
I just didn't make it.
oh, you switched it around. -3 minus 4 is still 7. He should have. He should have. Yeah, he should have got -3 minus 4, but yeah, he made it work correctly, the right side. Yeah, yeah, careful. Yeah, but on the assignment, I had you round to the 100th, so I wanted you to practice that. Yeah, good eyes though. But yeah, on the assignment, it's yours. Okay, so the distance formula always works. Now I'm gonna show you another option that you can use that we've actually been using all along with this one. So let's graph them. Let's graph these. We've got -5, 2 for D, and then I'm gonna show you another option, and you can choose. I don't mind whichever way you want to figure yours out today.
We have to label with the.
6, not necessarily. Only if you're using the distance formula, it's gonna be super helpful. But if you don't need it, that's fine. You don't have to. But I just thought it was easier just to have them right by the points you're finding the distance of. But either way. Okay, so when we were finding a distance on the coordinate plane, just one, when there was only one segment there, we connected them into a right triangle. That is an option. Let's just look at DF, even though it's number 3. But DF, will you connect the ends into a right triangle? You can still do that to find the length of DF. That's still an option, because that will allow you to count the legs. How long is the vertical leg? So label it 5, go horizontal.
6.
7.
Right.
So then for DF then, which is this number 3, we can just use the Pythagorean theorem, 5 squared plus 7 squared, which the distance formula does. But we can, this might feel a little quicker to some of you,
Yeah.
which is fine. We can do that. What is 25 and 49? 74, square root it, which we're doing the distance formula by doing that. 8 point what? 6 what?
It's just.
Oh, just 6, just 8.6? Okay, so then that is the length of DFD. Let's find the length of EF. So if you can just focus on that side only and just make a right triangle with its endpoints, you can do the Pythagorean theorem. This side is 2, how long is the vertical? 9. So then simply for EF, what's 2 squared plus 9 squared? 81, add them up. So that might feel a little quicker to you if you're fine making a right triangle off each side. What's the square root of 85?
9.22.
9.22, so that is this guy, 9.22. And then finally, again, you can make a right triangle connecting the ends of the third side. So we've got a 4 and a 9 again. So 4 squared, 16 plus 81, 97, square root of that. 9.8, 9.85 for the final. And then you can add them all together to get our perimeter. What do we got? 27.67 units. 27.67. So if your brain allows you to see those right triangles without getting all overwhelmed with everything, you can do that. Or the distance formula is fine, whichever one you prefer. Let's just do this last one with the Pythagorean theorem. So -3, 3. So yeah, if you're using the Pythagorean theorem, you probably don't need to label anything. 3, 5, -3, and -5, -6. So connect those. What side can we get right now? How long's the top side? 6. Okay, so then you can make a right triangle, just be careful. All the way over, so that's a 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 there. I don't even know what that is, that's I should have written. From R to U. Should wait a little. R to U. Right here, I can do 4 plus 81 is our x squared. So square root of 85, we've done that one before. What is it? Did I do that right? Yeah, 481. 9.22, so that will be this guy, 9.22. Okay, U to 5, -3 is T.
10.
U to T.
10 to.
So we got 10 and 2. So 4 plus 100 is our x squared. So x squared is 104. Square root it. 2. 10.2 for that guy. And finally T to
6.
S. T to S. 2 and 6. So 4 and 36 is 40. Square root it. 32.
You put point T on.
I put it on wrong.
You put it on. No, you're point.
Yes.
Well,
5, -3. Right there. So are the lengths off? Or did you tell me the lengths right? That's still 6, yeah.
I caught it.
So it's,
This one
that
wrong?
one's.
10.44. 10.44 there. Okay. 10.44, 6.32, and 9.22 and 6.
I think it's 30%.
31, 37. Did I hear you right or no?
31%.
Is that right? Okay, so you can choose. You can just make a right triangle off of each side and do that right here, or use the distance formula, whichever you so desire, whatever makes sense to you. Okay, some of these, several of them will have good straight sides that you can just count, so that's nice. But graph them, and in hindsight, this paper was probably not the best. You have to draw pretty dark to see them. Sorry. So draw dark. If you want a ruler, you can borrow a ruler. But make your points dark and your sides dark. So you've got about 22 minutes. No. 22. If you do finish, you can come correct it.